Hello everyone. So myself Muthu Natarajan, working as an assistant professor in the Department of Mechanical Engineering at Kamaraj College of Engineering and Technology. So today we are going to see a topic called 2D transformations. So this is one of the important topic in the concept of computer aided design. So as a mechanical engineering student, we all know how a transformation happens in a CAD software. So we will see that in detail. So the 2D transformation means the objects in 2D shapes, which is like a line, a rectangle, a circle, can also be called as 2D shapes. So how these 2D shapes are transformed from one position to another position. Say for example, we have multiple 2D transformations. So they are like, the types of 2D transformation includes, we have translation, rotation, scaling and reflection. So these are all the 4 topics which can be included in the concept 2D transformations. So as said earlier, 2-dimensional objects like lines, rectangles, triangles. So these are all the shape, how it can be transformed from one position to another position is called as 2D transformation. So we will see one by one. So from this image we can clearly see that this is the original image. Okay, so this image is going to be transformed into some other shapes. Say for example, in translation, the initial position of the object is to be transformed from its original coordinate to some other coordinates. So that will be called as translation. Rotation, as we all know that it has to be rotated about an angle with reference to some origin point. And the scaling is nothing but as we are going to enlarge or decrease the size of the particular object. So that will be called as scaling. So we will see one by one. So 2D translation. So 2-dimensional objects is going to be translated or moved from one particular point to another point. So here the 2D translation means translation moves all points in an object. So it is not possible to change one particular point to another place. So if we are considering a rectangle means, for example, if we are considering a rectangle means it has 1, 2, 3 and 4 points. So if you are going to transform or translate this rectangular position to some other point means all these 4 points has to be moved to the particular location. So from this image we can see that, so the coordinates x, y of a particular point, this is a point. So point number 1, it has to be moved to some other location. That location will be called as x dash and y dash. So that is the new coordinates of the first point number 1. So the initial point coordinate is x comma y and it has to be transformed or translated into another coordinate called x dash and y dash. So how the transformation happens in the software? So we all know that mechanical engineers, we use multiple software. Say for example, AutoCAD we use Creo, CATIA and ANSYS softwares. So in the like that we will use multiple softwares. So in AutoCAD, how the points are going to be transformed from one position to another position. So what are all the background programmings that involves. So like those concepts will be called as 2D translation. So I am going to check this with an example. So here there is a point whose coordinate is 2, 2. So the initial coordinates of the first point is 2, 2. In x axis it is in the position of 2 meters towards the right side and in y axis it is 2 meters in the above side. So that this is the origin point 0, 0. So from this position the coordinate of the particular point is 2, 2. So this position, this point has to be transformed to another location which is here. So this, it has to come to this particular point. How it is going to be moved? So in x axis it has to move 6 units. So from the given data it shows that the coordinate, initial coordinate has to be moved or translated to 6 units in x direction, similarly 4 units in y direction. So this is the concept they have given. So how the translation happens is, we will be using a matrix form. It shows that the final coordinates, okay, the final coordinates of the first point can be identified or can be obtained using the relation x, y plus the translation in x and y coordinates. Say for example, in this particular case I am going to translate 2, 2. So this is the original coordinates. So this original coordinate has to be transformed, this original coordinates has to be transformed into another point. So which is in tx, translation in x direction, it has to 6 units, and translation in y it has to move 4 units. So, how the transformation happens? The matrix form is x dash y dash equals to the initial position x and y plus the translation units in x direction as well as y direction. So, how it happens is, it is very simple. In x and y we have the coordinate as 2, 2. So, it has to be added with the translation coordinates. In x it will be 6 and in y it is 4 units. So, in just add these two matrices, we will get 8 and 6. So, this is the point, or this is the new coordinate of the translated position of the particular point number 1. So, how it will be moved? So, this, just imagine this is a graph, x axis and y axis. So, the initial point is 2, 2. The initial point is 2, 2. It has to move to 8. In x direction it has to be moved to 8, and in y direction it has to move 6 units. So, this is the final coordinate x dash and y dash, that will be 8, 6. So, this is the final position. So, likewise this is we have done for one dimensional point. Similarly, for rectangles or triangles or whatever the 2D shapes we have, we can use the same relations. So, I will go with one another example. Let us consider a simple triangle. So, let us consider a simple triangle whose coordinates are in x 1, 1, this is 2, 1, and we have 1.5, 3. Say for example, this is the initial coordinates of the 2-dimensional shape called triangle. So, this has to move or translated to 4 units in x direction as well as 2 units in y direction. So, this is the given or the desired thing we need to change. So, how it will be translated? So, for point number 1 we have to do each point, for each point. So, in a triangle we have 3 different points. So, point number 1 is 1, 1, the coordinate of point 2 is 2, 1, and the coordinates of point 3 is 1.5, 3. So, for point 1 the new x dash and y dash will be, so the initial location is 1, 1, it has to be added with the final coordinates 4, 2. So, the translation coordinate is 4 and 2. So, the final answer will be 5, 3. So, this is for point number 1. Similarly, point number 2 is x2 dash and y2 dash, that will be 2 and 1. So, the 2 and 1 has to be added with the 4 and 2. So, that will be 6 and 3. So, that is the coordinate for second point. Similarly, for third point it is very simple, we can directly add the coordinate values with the given value. So, 1.5 has to be added with the 4, that will be your 5.5, and 2 has to be added with 3 and it will be 5. So, these are all the 3 points. Now, what we have to do is we have to mark each points of the new coordinates. So, which is 5, 3. In x direction it will be 2, this is 5, 3, 5, 3. So, here it will be 5, 3. So, I will just erase these things so that it will be easy for us to follow. Okay. So, this is 5, 3, then 6, 3, 6, 3 will be here, and 5.5 which is in between these 2 points, and the 3 is, I mean the 5 will be located more than 3. So, this is the final translated position of the particular triangle. So, from this position it has moved to this location. So, this is how the translation happens in a CAD softwares, or we can do it manually as well as. So, using the relationship x dash y dash coordinate will be obtained with the help of xy coordinates has to be directly added with the translation in x as well as y direction. So, this is how translation in 2-dimensional objects happens. So, we will move to the second topic, which is rotation. So, the rotation, 2-dimensional rotation, similar to the translation, what we have done in translation is we are moving each and every points to the new coordinates based on the translation values. Say for example, in x direction we have moved to 6 units, and in y direction we have moved to 4 units. Similarly, how the object is going to be rotated. So, that is we will see in rotation. So, just assume this is the line which is need to be rotated about a particular angle. So for this we have two different points, 1 and 2. So in the earlier case, the transformation which is called as translation, in translation we use point for transmitting from one place to another place, but in rotation we will use two dimensional shapes only, because the point cannot be rotated at an angle. So for that we need some two dimensional shapes. We can use line, even triangles, circles. What circle cannot be possible, we can go with rectangles and squares also. So how it is being rotated about the particular axis means, here we have the matrix form as the initial coordinate of the first point is x comma y, that it has to be converted or moved to the new coordinates x dash and y dash. So how we are going to obtain the x dash and y dash for rotation is, it is very simple. The matrix form is cos theta minus sin theta and cos theta. It has to be multiplied with the initial coordinates x and y. So this is the xy coordinates. Earlier case we use the origin point or the initial point. Similarly, the initial point has to be multiplied with the matrix form of cos theta minus sin theta and cos theta. This theta, okay, this theta, what is the theta means? The angle at which the initial shape needs to be rotated from the given axis. So here the initial position is, say for example 20 degree, means it has to be moved to 50 degrees. So how it will be moved from the original position. So that is what rotation is all about. So how we are going to do is, similarly we will see it in an example. Okay, so just assume in the case of a triangle, we have seen in translation, we will go with a rectangle. So this is 1 comma 1, this is 2 comma 1, this is 2 comma 2, and this is in y direction it is 2 and in x it is 1. Okay, so this is the initial coordinate of the rectangular shape. This has to be translated or this has to be rotated at an angle of 45 degrees. So how it will be transformed to the final position? So that's what the question is. So here we have the relationship x dash y dash is equals to cos theta minus sin theta and cos theta. So this is the form, it has to be multiplied. In translation we have added the matrix form, for rotation we need to multiply the form. So here the xy needs to be multiplied. So for initial position of 1 comma 1, okay, so for 1 comma 1 point cos 45 degrees, because all these points has to be rotated at an angle of 45 degrees, so that the final object will be tilted. So cos 45 minus sin 45 and cos 45, it has to be multiplied with the initial coordinates 1 comma 1. So whenever we multiply the matrix form, we will get the new coordinates, okay, new coordinates of x1 dash and y1 dash. So it will show or it will give an exact value. Similarly for point 2 also, for 2 comma 1 also we need to multiply. For that we can simply change these values alone. So 2 comma 1. So the matrix form of the initial angle values will be the same, because the theta value is common for all these points, which is we have taken 45 degree as an example. So for that particular 45 degrees we have the matrix form is common for all the 4 points, whereas these individual points, this xy coordinates needs to be changed. So that's the only requirement. So whenever we are changing all the 4 coordinates into this matrix form, we will get 4 different new coordinates. So when after changing these things, how it will be look like is, so this is how the final triangle after rotation about an angle 45 degrees. So this is how the initial values has to be changed. So this is for rotation. Similarly we have 2 more combination, which is called as scaling as well as reflection. So we will see scaling now. Okay, so similar to the translation as well as rotation, we have another concept called as scaling. So why scaling is very important, which is if you are having a smaller object and it will be like very minute in the original screen. So how we are going to see the exact shape in a enlarged version? So that will be called as scaling. So scaling changes the size of an object. It involves two factors, which is it has to be scaled in the x direction as well as in the y direction. So because we are seeing about 2D scaling. So I am having an object 1, 1. So there is a cube of size 1 centimeter cross 1 centimeter. So which is very small in size. How for our visual presentation we need to enlarge the size of the particular square. So how it can be enlarged? In x direction it has to be, for example, in 5 units we are enlarging means 5 centimeter cross 5 centimeter. So how this scaling has been done? So we will see that with the matrix form. So before that there are two options. One is scaling for increasing the size of the object as well as scaling for reducing the size of the object. So we have two notations, which is we will call it as both as scaling factors or scaling ratio. So what is 1 by 2 or what is 1:2 and 2:1? So that meaning how we can easily remember is 1:2. So which is just in place of this colon we can use a slash. So 1 by 2 means 0.5. Similarly 2:1. So use a slash here. 2 by 1 is 1. So sorry, 2 by 1 is 2. So from this factor 0.5 means we are reducing the size of the particular object, which is from 1 it has been scaled down to 0.5. Similarly from 1 it has been scaled up to 2. So this is scaling increasing factor, this is decreasing factor. So this is how scaling happens. So from this image we can clearly see that this is the initial object. This is the initial object of any particular size. Say for example 1 cross 1, it has to be enlarged in size. So to a new coordinates like 5, 5. So this is scale enlarging factor. Similarly, let us consider this is the bigger triangle as the initial position. It has been stepped down or scaled down to the reduced portion. So this is how scaling will be done. So for that we have a similar matrix relation. So we will see that. So here the initial coordinates, okay, similarly for each and every points we need to scale the values. For initial position, that is x, y, that has to be scaled up to a factor called sx, sy. So see here the formula is sx 0, 0 and sy, it has to be again multiplied by the initial factor. So we will see with an example. Say for example we will use the same triangle 1, 1, 2, 1, 1.5, 2. So this is the initial size of the particular triangle. It has to be enlarged. So I am going to enlarge the factor by 3 units in x and sy direction as 3 units. So I am going to multiply the triangle by 3 bigger units. So it has to be enlarged in such a way that the final coordinates has the 3 times of the initial value. So how it is going to be done is x dash y dash will be equals to sx 0, 0 and sy. What is sx value is 3, we have 0, 0 and 3. It has to be multiplied with the initial coordinates 1, 1. So how it will be done? So the matrix form 3 into 1 is 3, 0 and 3 into 3. So the final coordinates of the first point is 3, 3. So that is the final coordinate. Similarly for 2, 1 coordinate is 3, 0, 0, 3 and 2, 1. So it has to be multiplied. 3 into 2 is 6 plus 0, 0 plus 1 into 3 is 3. So this is the second coordinate x2 dash and y2 dash. So this is the second coordinate final position. For third coordinate 3, 0, 0, 3 has to be multiplied by 1.5 and 2. So 4.5, 0 and 6, 4.5 and 6. So we have the three values as, the first one is I will write here 3 comma 3, the second position will be 6 comma 3, and the final position is 4.5 comma 6. So how it can be changed is, so these 3 points needs to be plotted in the given origin points. So for example, the initial point is 3 comma 3, in x direction 3 and y direction also 3. So this is the initial point 3 comma 3, the first point. Second point is 6 comma 3, similarly 6 comma 3, 6 comma 3, and the third point is 4.5, which is in between 4 and 5 and 6. So we will plot. So this is the enlarged version of the given diagram. So the initial diagram, it will be like, it was like 1 comma 1, 2 comma 1 and 1.5 comma 2. So whenever we are measuring the dimension between these 2 points, it will have 1 meter or 1 centimeter. Similarly here also 1 meters. So this is y coordinate is 1 and here the y coordinate is 2. So whenever we are subtracting, we will get 1 meter. Check here, the x coordinate is 6 and 3. So 6 minus 3 is 3 meters. And similarly here also y coordinate is 6 and 3. So 6 minus 3 is 3 meter. So initially the shape or the dimension of the first triangle is 1 cross 1. Now it has been enlarged to 3 cross 3. It is not desired to use the same factor for both x and y. We can go with different options also. So this is how scaling and how the scaling option is done in a CAD software. So what are the background processing it involves? So these are all explained with the help of a matrix format. So this is how scaling is done. And the final translation object is, we have reflections, 2-dimensional reflection. So what is reflection is, it is very simple, just like mirror option in AutoCAD. So how the shape or how the initial position is being mirrored about the axis. So this shape 1 is being reflected or mirrored about x axis, and herely the object is being mirrored with respect to y axis and it is being referred with respect to z axis. How mirror option of initial shape is done, that will be called as reflections. So for each and every reflection about particular axis, we have different formats. So for reflection about x axis, we need to use the form as 1 0 0 minus 1 has to be multiplied with the original coordinates. Similarly, reflection about y axis means minus 1 0 0 1 has to be multiplied with its corresponding coordinates. Similarly, for z axis minus 1 0 0 and minus 1 has to be multiplied with xy coordinates. So this is how reflection done with respect to any particular axis. So for x axis, we will use 1 0 0 minus 1 multiplied with the xy coordinates. Similarly, for y axis minus 1 0 0 and 1 has to be multiplied with x and y, and for z axis minus 1 0 0 minus 1 multiplied with xy coordinates. So this is the 4 different translations in a 2-dimensional objects. So we have 4 options. First one is translation, second one is rotation about a particular angle, third one is scaling, we can enlarge the scale or reduce the scale to a certain limit, and the fourth one is reflection, which we call it as mirror. So mirroring about any one axis. So this is reflection. So these are all the 4 topics which can be covered under the overall subheading 2-dimensional transformations. So this is for 2-dimensional object. Similarly, we have the 3-dimensional transformations also. So for that also the matrix form will be changed to 3-dimension. X, y and z coordinates will also be included for 3-dimensional transformations. Thank you.